Hello everyone. Today we're going to be covering limits, and the first technique you'll need to know for limits is factorization. So we're going to go through a few different factorization methods, and then we're going to talk about when to use factorization, when not to use it, and how to solve limits. So we're going to begin with the easiest factorization method, and that is looking for common factors. We're going to move straight into an example for this one because it's quite simple and you've probably done this many times before. So let's say we have 6x squared plus 3x. We're going to look for the highest common factor of both of these terms, and we're going to move that out the front and then multiply it by a to get 6x squared and b to get 3x. So the highest common factor of 6x squared and 3x is 3x. And what do we need to multiply that by to get 6x squared? That's just 2x. And what do we need to multiply that by to get 3x? And that's just 1. And that is your first factorization method. The second factorization method we will be discussing is the sum product pattern. The sum product pattern. We've also probably done this one a few times before, but we'll just cover it again. Let's say we had x squared plus 7x plus 12. We need to find two values that add to b. In this case, b is equal to 7. Middle term here is b. And multiply to c. In this case, c is equal to 12. So I'd like you just to think 5 seconds, two numbers that add to 7 and multiply to 12. And we know that'll be 3 and 4. So we write this out, x plus 3 and x plus 4. And that's how you factorize when two numbers add to b and multiply to c. The next method of factorization we'll be discussing is the grouping method. Now, you're going to use this when you have an equation that fits the form ax squared plus bx plus c. So the only difference between this and the sum product pattern is you have this a value out the front. Let's move on to an example now. 2x squared plus 7x plus 3. The first thing you're going to do is use factors of AC, factors of A times C that add to B. So let's first calculate AC. AC, 2 is our A value, and 3 is our C value, so AC equals 6. And B is of course 7, that's our middle term here. So we need to figure out two factors that add to 7 but multiply to 6. And in that case, that'll be 6 and 1. So we're then going to rewrite this out now with the 7x split into these two factors. So we have 2x squared plus 6x plus 1x plus 3. So you can see here, the 6x and the 1x add together to become 7x, but they're also factors of 6, AC over here. We then need to split this equation into two halves. So let's consider this as one half and this as the other half. And we use the common factor method to simplify these sides down. So the highest common factor of 2x squared and 6x is 2x. So move that at the front and simplify this. So 2x multiplied by what equals x squared, 2x squared, sorry. that's x, and 2x multiplied by what equals 6x, and that is 3. We then do the same for the other side, the highest common factor of x plus 3. Obviously there is none that fits into both of those. So we have this 1 out the front, and we put x plus 3 in there again. We can then group both of these sides into 2x plus 1 multiplied by x plus 3. So we've combined these two terms here and these two terms and split it into 2. One of the last factorization methods that we'll be covering is perfect square trinomials. So let's say we have x squared plus 10x plus 25. You're going to look to B here and see, when you halve it, is it the square root of C? So in this case, half of 10 is equal to 5, and we know that 5 is equal to the square root of 25, which is C. Therefore, we can write this out as x plus 5 squared. Now the final factorization method we'll be covering is difference of squares. So let's say we had x squared minus 9. This is only going to work if you have a negative in the middle. Let me show you why that is. When you factorize this, we get x minus 3 multiplied by x plus 3. And when we expand that, we get x squared plus 3x minus 3x minus 9. So because of that negative, we can completely cancel out these two terms, because the addition and the subtraction cancels each other out, and we're left with x squared minus 9. So difference of squares only works when you have the negative in the middle. Now, you're probably sitting there wondering, why did I just sit through 6 minutes of this guy talking about factorization when the topic is limits? And let me explain that to you now. Let's say we had limit x minus 5 as x approaches 6. So in this case, what we're doing is subbing 6 into the x value, and we get 6 minus 5 equals 1. All well and good. That's saying as x approaches 6, we get a value of 1. We get closer and closer to that value of 1. But let's try a slightly harder one now and see if subbing in for x still works. So we have limit of x plus 2 squared minus 4 on x as x approaches 0. Now you might already see the problem here if you're subbing in 0 for x. We get 0 plus 2 squared minus 4 on x. So we get 2 squared minus 4 on 0, which is equal to 0 on 0. Slight problem. If you get a value like this, 0 and 0, it means you need to factorize. So let's retry this one now and expand before subbing in 0 as x. So we get limit of x plus 2 squared minus 4 on x, which is equal to x squared plus 4x plus 4 minus 4 on x. Now if we simplify this numerator, the positive 4 and the negative 4 cancel out. So we get equals x squared plus 4x on x. And then when we divide both of these terms in the numerator by x, we get x plus 4. And now we sub in 0 for x. So if we let x equal 0, we get 0 plus 4, which equals 4. So as x approaches 0, we get closer and closer to the value of 4. So let's finish off this video now by combining a lot of the skills that we've learned today. So this question is probably on the harder side for limits. Limit as x approaches 2 to 3x squared minus x minus 10 on x squared plus 5x minus 14. Now let's look first towards the numerator here. We can see that we have an a value out the front, so we need to use the grouping method for the numerator. And for the denominator, I'd like you to just have a look, use 5 seconds and figure out which method we need to use to factorize this bottom side. If you guessed the sum product pattern method, you'd be correct. Sum product pattern method. So we're now going to factorize both the numerator and the denominator. So we have 3x squared minus x minus 10. So with the grouping method, we need to find AC first. A times C equals negative 30. And B, which is equal to negative 1. So we need two values that multiply together to get negative 30 and add together to get negative 1. In this case, that's negative 6 and 5. So we're going to rewrite this now with that middle term split. 3x squared minus 6x plus 5x. So we still have negative x when you add those together, but it's now separated. And let's also start factorizing the bottom. We need two values that add to 5 and multiply to negative 14. In this case, that will be 7 and negative 2. So we have x plus 7 and x minus 2. And then let's continue factorizing the numerator. So we're going to split this into two halves. Consider this as one half and this side as the other. And let's factorize this into two sides, like we did in the grouping method. So the highest common factor of 3x squared and negative 6x is 3x. So I'm going to bring the 3x out the front. 3x, so let me put an equal sign here, multiplied by x minus 2. And we'll do the same thing with the other side. The highest common factor of 5x and negative 10 is 5. So 5 multiplied by x to get 5x and negative 2. And you can see here that we now have these two same sides. So we can factorize this again as 3x plus 5 multiplied by x minus 2 on x plus 7 and x minus 2. And you can see now that we have these same things on the numerator and denominator, so we can cancel them out. And then we have 3x plus 5 on x plus 7. So we can now sub in our value of 2, which was at the very start. I know this is quite a long process, so we can sub in our value of 2, and we get 6 plus 5 on 9, which is equal to 11 on 9. And that's our value that is approached when x gets greater to 2.